Let's continue on our introduction to programming using Python. Open a browser and go to this URL. This will bring you to this repository again. Click the green button, clone or download, and go ahead and re-download this. I am saving this to my desktop. And I am extracting this. With Anaconda Navigator, we can launch the Jupyter Notebook. Let me go ahead and clean up some of this notebook. I'm visiting once again, similar to the last lecture. We're going to go to desktop, intro to programming Python master, and we will start with intro to Python 3. So, how do we explore data elements in a data frame? With Panda, we are able to load data in an Excel-like data structure called data frame, which we have covered in the previous notebook. So, in Excel, if you want to do something, some sort of repetitive action, say calculating the final grade, you can fill in the equations for a single row, and then you Control C and mouse drag to apply the same single equations to the rest of your data, your spreadsheet, and the Excel will be smart enough to use the correct shell in each row for these calculations. In Python and in any other programming languages, this type of repeating actions need to be performed using what is called a loop, or sometimes it is also called an iterations. So let's start by looking at our data. And this is the famous iris flower data set that if you look at any of the machine learning tutorial, you will see this data set being used. The data sets have been uploaded into the repository as well, so you don't need to download anything extra. We start by, let me go ahead and clear all of the output. I will update this when you look at this video. So we want to import pandas, our pandas library. We want to load the data set using the rich CSV. We want to look at the first 5 rows, and we want to analyze the shape. We have covered all of this in the previous notebook. So this is what we see. This time, the iris.csv data don't have a header. So therefore, instead of a formal column header, like the data set we had from the last time, we see 0, 1, 2, 3, 4. We know that the columns are arranged in the following manner. The first column is the sepal length, the second is the sepal width, the third is petal length, and the fourth is petal width. The last one is the class of the flower, Iris setosa, Iris versicolor, and Iris virginica. So we can set the header for our data frame by data.columns equal to an array containing the text that we want to make into our column header. So now instead of 0, 1, 2, 3, 4, 5, 4, we now have sepal length, sepal width, petal length, petal width, and class. So we want to look at the sample length of one record within our data set. Pandas data frame allows us to do that. If we want to bring this information out in a nicer format, we can put multiple things together and have the print statement from Python help us. So let's say I want to bring this out for record 0. I see sample length for record 0 is 5.1. I can do it for the first 5 rows by typing the print statement 5 times. Run that. So it works for, say, a handful of records, but let's say I want to do it for 20, 50, 100 records. This no longer works. And to do this, we need to use what is called a loop. The structure of a loop looks like this. For a value I in a range between 0 and 5, I want to run the following statement. Print sample length for record. Value I is data sample length at row I. There's only one print statement here, but it in fact printed out 5 times. So let's look at this code again, and this time I add one more print statement which prints out the value of I itself. So you can see for each value of I in range 0 to 5, and the range 0 to 5 here gives you 0, 1, 2, 3, 4. So from 0 to the integer value less than 5, less than the final value here, then I is going to be set to that value, and therefore any statement that you made in here that you use I is going to carry that value. So with I equal to 0, sample record is 0. The data at position 0 of sample length is 5.1. Record 1, record 2, record 3, record 4. So that is the basis of loop. So with that, let's go ahead and start looking at, let's say we want to find the Euclidean distance between two records in the iris data set. This time we want to set up manual data called point data. You can find this point data in slide 5 of the data. Let me bring that up. Of the data explorations. Slide 4 and 5. So this is this data set P1, P2, P3, P4, 0, 2, 3. Oh, I did indeed make a mistake. So it should be 0, 1, 3, 5. You will not see this error when you download this. And 2011. Python has a library called math that will help you with some of the standard math equations. So looking at Euclidean, the Euclidean distance is the square root of the sum of the square of differences between corresponding attribute of row X and row Y. In this case, if we want to compare, again, look at the result table here. If you want to compare the Euclidean distance for all the points within our data set, we're going to compare P1 again, P1, P3, P4, 2, P4, P2 against P1, P2, P3, P4, P3 against P1, P2, P3, P4, and so on. And you can see a pattern emerging here. For each point, we iterate through all of the points. And this is what is called a nested loop. So for each point I, going from 1 through 4, we were going to analyze the distance between this point I with all the point j, but also between range 0 and 4. So what you have here is the distance is the square root of point x, data x. So this is x at row I minus point again x but at row j, and power mean power to the power of 2. So this is the int side here, xk minus iyk to the power of 2. And then because there are two attributes x and y, so the second is also point data y at position I minus point data y at position h to the power of 2. This plus sign here is equivalent to the sum. We are adding them together. And let's run this and compare. So this turn between P1 and P1 is 0. P1 and P2 is 2.82, P1, P3, 3.16, P1, P4, 5.09. And as you go down, you will see the value that we have here match the value in the slides. And then this is where Python's community support helps to make it better. We have a lot of code to type in here, and to be able to, it's nice to have the math library, but sometimes the math library of Python is very verbose. So what we have is a library called SciPy, which is also, again, a free and open source library used for scientific computing and technical computing. They have equations and functions for optimizations, linear algebra integrations, interpolation, special functions, Fourier, fast Fourier transform, signal and image processing, and so on. So this time we'll look at a function called square form in p distance. Square form, take a vector from distance and convert it to a matrix. So basically, what we have here is a vector by distance, and what we have on this side is a distance matrix. So square form convert this to this format. pdist actually attempt to help you with this loop. It will calculate everything, the distance of everything in here, comparing to everything else. So it should be noted that the point data we have here is not yet a data frame. I convert that to data frame using pandas.dataframe and input that data structure, and I assign it to variable df. I'm going to bring df out. And then pandas data frame, I'm going to call square form. Look at the way the parentheses highlight. So this, you can see the two green. So square form is being applied to the internal pdist function. The pdist function is going to apply to everything belong to df using metric Euclidean. And looking over here, you can see Euclidean will help you to compute the Euclidean distance between two one-dimensional array. So if I run this, the first print show me this data format, which look very similar to the table we have here. And then in the second pandas of data frame, it show me the result. This time, the numeric value are the same, but the format is exactly as what we see on the slide to the left. So this is the questions one in your homework. I want you to modify the code, fill in this blank, so that it calculates the pairwise distance of the point data frame using the city block distance. So basically, this is your data set, and I want to calculate the city block distance, and you should expect to see something that look like this first matrix. This is the L1, Minkowski distance equivalent to the city block distance. So what you need is to look through this and identify the correct string value here, metric value here, to let you run the city block and fill this in. And then we are going to look at the Mahalanobis distance. This time, I would like to introduce you to another supporting package called NumPy. NumPy is free open source library support operations for large multidimensional array and matrices, as well as high-level mathematical functions for this array. So let's look at this slide. I have this covariant matrix. Covariant matrix 0.2, 0.3, 0.2, 0.3, and NumPy. If I import NumPy, but I said this is basically a shorthanded name for the library, so I can code NP instead of typing out entirely NumPy. So I want to create a NumPy matrix from this array set and name it covmat. So this is our covariant matrix. Matrix A 0.5, 0.5, B 0 and 1, C 1.5, 1.5, and so on. So the Mahalanobis distance between A and B, according to the equation, is matrix Mahalanobis x between x and y is x minus y transpose multiplied by the inverse of the covariant matrix multiplied by x minus y. So A minus B dot T, this is the transpose signal for NumPy matrix. Covariant matrix, this is the inverse functions, and A minus B again. And let's look at that. We have the covariant matrix, and we have phi, which is the value that we have here. And this is your second questions in your homework assignment. How do I calculate the Mahalanobis distance between point A and C, where the C is the value given here? So once again, fill out what is needed, modify and fill what is needed here, and give me the correct argument for the print functions. So another is similarity measurement, slide 14 or 13. Given two, in slide 14, I'm using this x value, x vector and y vector of 1, 0, and 1. And I would like to introduce you to the concept of conditional statement here. If, else, if, else. So basically, if this happened, do that. Otherwise, if the other thing happened, do some other thing. Else, do something else. So let's start with for a variable f01, f10, f00, f11 is defined in this slide, and I want to set everything to 0. So for I in range 0 and 1, I want to walk through every single value of x, and being that x and y have the same size, it will work for both of them. I only need a single index because we are comparing this against this, this against this. So we are comparing them on the same index. So if xi equal to 0 and yi equal to 1, so number of attributes where p was 0 and q was 1, then I would increment f01, else if this is 1 and this is 0, I would increase f10, else if this is 0 and this is 0, I'm increasing f00. And finally, else, I increase f11. This is the only choice that I have left. And to run this, oh, sorry, I have forgot to run this. So you can see f01 is 2, f10 is 1, f00 is 7, f11 is 0. So we can calculate this value using this Python code. So this is now you have question 3 of your homework assignment. Based on the above similarity measurement, I want you to write a Python code to calculate the simple matching and the Jaccard coefficients as based on the equations on slide 14. And finally, on questions 4, with all of these preparations, I want you on your own to analyze slide 15 and complete the entire body of code to calculate the quotient similarity equations for two vectors d1 and d2. I want you to create the correct input for d1 and d2. You can see the hint is look at how I created for x and y. I want you to calculate the inner product. So you can see the inner product d1, d2 is calculated using these equations. So basically you are taking the corresponding value at the same index and multiply them with one another and add up the value. I want you to calculate the length of d1. Same thing, you probably need the math equations for the square root, but then inside you are multiply the individual values together. So each value at each index are squared up. Same thing, calculate the length of d2. I already put the equations here. Quotient similarity of d1 and d2 is the inner product divided by the product of length d1 and length d2, and print out the result. You can have the final result for cross-check here. It should be 0.3150 something something something. And that is the Intro to Python 3 notebook. Let's go ahead and look at the next one, Introduction to Python 4. So with the knowledge of loop and if else, we return our focus on data frame, this time to examine how to perform data cleaning and pre-processing tasks. At this point, I should note that the order of the programming are not exactly following the order of the data mining lecture. And the reason is that some of the programming technique, you need to know loop and if else first before you can figure out how to do data explorations programmatically. So this is why we have the programming lecture at the very end of each module. This time we are using the breast cancer diagnostic dataset from Wisconsin. It should be noted that you should be using the original dataset. If you do a search on Google, you might run into a descriptive dataset which has all of the missing data already cleaned up, and we don't want that. So we import Panda, give it a shorthand notation PD, data equal to pj.read CSV, data slash breast cancer wisconsin.csv. There is no header, and then we manually set the header. So we are doing very similar thing to the programming lecture note 3. And 1 second. So each of this has a unique sample code, and we want to see the issue of data duplications. So we are going to go ahead and drop this column. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. The first data exploration that we want to look at is missing value. If you follow this link, the link that we have here, you can see that the missing values are replaced by the question mark. This does not impact how Panda see the majority because you can see everything here a numeric integer value. So if you run data info, you can see almost everything is integer. However, we have this column that has an object on that. And this will impact how conversion are performed on each column. So import NumPy. I use the sum functions in NumPy and to sum up an array of type int64. And then I try to sum up the column data bare nuclei. Looking at this, you see this row right here, 0 plus 1 plus 2 plus 3 plus 4 is 10. So this is a numerical sum. However, for the column bare nuclei, it seems that we are appending all of this value together. And the reason is that you can see the question mark here. This is an object vector, and when you try to sum an object, instead of converting it to numerical value, it will just concatenate everything together. We want to make this into something that we can calculate. So we want to replace the question mark with a notation from NumPy to indicate that this is a missing numerical value. The notation is NaN, or it stands for not a number. So this can be done by calling the replace function in data frame. It replaces the question mark with np.nan. And then we are going to, in this for loop, we go through each column and we bring down the column and we calculate how many entry within that column that is an NaN. And we add the count together. With this, you can see here, on every column, everything is 0 except for bare nuclei. So we have 60 missing value at column bare nuclei. I am printing out the descriptive information of the data frame again, and you can see this is why bare nuclei is an object. Try to run that. Even after I change it to not a number, because it is not a number, when I try to run it, it returned an error. In order to fix this, we actually need to convert it to numeric value. So after converting the numeric value, you have it here as float. There are two ways, now that we know where the missing values are, there are two ways that we can reprocess the data to take care of them. We can replace the missing value with the median value throughout the data set, or we can simply omit it. And again, to decide using one or the other is very situational, and it depends on what data you have, whether you have any understanding of the distribution of the data or not. You might, in fact, have to try both and see which outcome makes sense. So this is an example where we fill NA with the median of your data. So before replacing missing value, I have NaN, and after, if you look back here, you see that we have a lot of 1. So I think the median value for this data set, this particular column is 1. 1 right here. We can also drop the not NA by using this, drop NA. In this case, you see the NaN is gone to 1.0 move up, and there's a value moving up. So let's go ahead and drop the outliers. Oh, sorry, the missing value, not the outlier. Now let's look at the outliers. Outlier data instances that are considerably different from the rest of the data set. Here, you learn a new item which is called a cell magic. The cell magic starts at the very first line of the cell with a percentage sign. In this case, it tells us that we want to also display graph within the data. We take the data pandas. Panda actually has graphical capability embedded, and I want to graph it as a box plot. So if I run this, you can see how NotePython notebook allows you to visualize the data. Clump thickness, uniformity of cell shape, marginal adhesion, and so on. Looking at this, you can see in box plot, the green line in the middle is your mean. The top and bottom are your percentile. This bar right here are the typical max and mean. But if you have the dot right here, it implies that this are the outlier. So you have 1, 2, 3, 4, 5 columns with outlier. To discard the outlier, we can compute the z-score and remove anything that is outside of 3 standard deviations away from the mean. So I can calculate that. I can calculate the z-score. What we can have is we can use SciPy once again. So you can see how the value here are the same, almost the same, very close, very calculated, very close together. So instead of manually calculate them, you can also use SciPy, import the stats function of SciPy and use it to calculate the z-score so that you don't have to remember the equations. The z-shape and the data shape are the same. This indicates that you have the z-score value for every single entry in your data set. And now SciPy therefore allow you to filter your data. So this is my panda frame, and putting my panda frame here, I can enclose inside a conditions. I want to take the absolute value of my z-score for this row, and I want to filter out, I want to keep only anything that has the absolute value less than 3, meaning that it is greater than 3 or less than or equal to -3. And I want to do it to all of them, x is equal to 1 for every single column. After running that, you can see that I only have 632 rows left. We have removed a number of outliers. The next issue is data duplicate. You can identify duplicate by using dups equal to data.duplicate. This will let you create the entry. So we actually have, out of 632, we have 234 rows are duplicates. This is an example. We know exactly these 2 rows are duplicates. You can see how all values are the same. And then again, pandas give you the ability to go ahead and drop the duplicate. So 683 minus 234 give you 449 left. You can also have the ability to do aggregations. This is slide 3 of the data preprocessing. We're looking at a data set called DTW, Detroit Metro Airport data. In this data set, we're starting out and we have 2 data columns. One is the date and one is the precipitation's value. We want to convert this into a series by taking the date and convert that into an index, and take the PRCP and make it into the value of that index row. So now the data format becomes something like this. Instead of having 2 data types, you now have only 1 data type. And let's go ahead and plot that. Again, daily is a pandas object. It is a task series and not a data frame, but it is still a panda object, so it has a graphical ability. I want to graph a line with a fixed figure size. I want to set the title, daily precipitations, and the row right here, meaning that I'm taking the variance on my daily series and use it in this statement. So you can see the variance is 0.0530. Then this is what the graph looks like, and it doesn't make a lot of sense. Pandas allow you the ability to change the granularity of analysis, which is one of the here, changing the scale. So this is one of the aggregation technique for data preprocessing. By the group by functions, you can read the documentations of the group by here. So monthly data is now daily data. Group by frequency is M. M stands for month. So I want to apply a group by filtering out. I want to look at this data and I want to base on the index, not the value. I want to look at the index and I want to group them together by month. So all the value of month January together, all the value of February together. And I want to sum all of this. So access, plot can applied, figure side, and I have the monthly precipitations. Once again, you can see how looking at the for group yearly value by month allow me to look at this from 2002 all the way to 2018 in a better form. So with that, you have a question 5 of the assignment. If I want to group the data by year, what should I do? Sampling size 7 is a common approach to facilitate data reductions. And here, I want to focus on 3 things: sampling without replacement. In sampling without replacement, you will see how I keep trying to rerun this. And anytime I get a different rows, I'm only looking at the first 10 row of the data in my temp data set so that we can observe this. Instead of specify say n equal to 4, you can also specify fractions. So if fraction equal to 1 out of 0.1 out of 10 row, I get 1 row back equal to 0.2. I get 2 row back equal to 0.35. I get also 2 rows. 0.225. Oh, it's not even. If it is 0.5, I will get 5 rows back. Now, with replacement, so you can see here, even with 0.5, I don't see any repetitions. With replacement, then there is duplication, because meaning that after you run them for the first sample, you replace that and you run them for it again. So you can see this is 295, this is 098, 546, 031, 042. Now this is one case where with replacement I have duplication 0 and 0.